So, what are the typical stages in a data science project? Let us see. Here are the overall stages in a data science project. We first acquire data from data sources. Then we transport data from the data sources to the central data center. We process data to transform them into information. We store and manage data. We analyze the stored data to derive insights. We use insights to predict future events and behavior. We prescribe recommended actions and validate them for deployment. Let us now deep dive into each of these stages. The first stage in data science is data acquisition. Data for data science comes from a variety of sources. We have the traditional RDBMS systems that store data from internal business applications like CRM, inventory management, financial accounting, etc. We then have data that is available in flat files like CSV files. These are usually fetched from third-party businesses or products. We have real-time streaming data from internal and cloud sources. We have social media data from websites like Twitter and Facebook that can be used to monitor customer behavior and comments on companies' products. We have mobile data, including location data, that needs to be captured and linked. We have data from IoT devices that need to be collected too. Acquiring data from these various sources require building suitable components to these systems. These connectors work either in batch mode or real-time mode for data collection. The next stage is data science is data transport, from the point of collection to the processing centers. Please note that this is big data. Volumes are heavy and they need appropriate pipelines to transform them, possibly around the world. There are multiple forms in which transport happens. There are batch mode files that can be transferred through FTP. We have real-time streams that connect and work on a continuous basis. The streaming technologies can be native or standard. A very common model in big data is the publish-subscribe model. Here, the providers of data will publish them into a queue like Apache Kafka, and the subscribers will pull the data out of the queue. An important consideration for transport is scalability. Imagine having to transport mobile data collected from thousands of devices to a central location in real time. There is a loss prevention issue that needs to be considered during this transport. Throughput requirements can be stringent for real-time applications. Next, we move to processing of data. Processing of data involves various types of activities. We start off with cleaning data to remove bad or incomplete data. We then standardize data to match analytics requirements, like standardizing data formats. We link data from various sources. For example, customers' order information will be linked to a customer's static characteristics and a customer's social media activities. Data is then transformed to, like converting strings to numeric representations. Data is aggregated to create summaries based on different segments and profiling variables. There is also the need to transcribe video and audio data into their equivalent text for analytics. The next phase of data science is data storage. This is big data, and it requires appropriate storage resources and strategies for optimal functionality. Storing big data requires resources like hardware, software, disk space, and network bandwidth. It also requires human resources for setup and administration activities. Data needs to be guided by a good data architecture to avoid it from becoming a data swamp. The architecture and the infrastructure should be scalable to accommodate tera and petabytes of data. The setup should be fault tolerant by design. It should also provide acceptable performance for both data ingestion and analytics activities that are required. So far, we saw the heavy lifting, dirty work in data science. We now get to the more exciting part, analytics. Analytics starts off with segmenting and profiling data through manual, graphical, or automated tools to discover and understand patterns. Business analytics perform exploratory data analytics to discover hidden trends. Correlation analysis is performed to understand relationships between entities, characteristics, environment, events, behavior, and outcomes. Statistical techniques are used to build models and perform statistical tests. Explanatory analytics focuses on finding reasons for behavior seen. Tools and automation are a key part of the analytics phase to make it both productive and cost-effective. Next comes the rockstar stage within data science, predictions. In order to build models, data need to be pre-processed to convert them into forms that can be understood by machine learning algorithms. Algorithms don't understand text, but only numeric values. Data is split between training sets and testing sets for model creation and validation. A model is created using appropriate machine learning algorithms. Models are validated for accuracy and performance. The model creation and validation processes are iterative. It is repeated with changes in algorithms, data sets, and techniques until desired levels of accuracy and performance are achieved. The final stage in data science is validation, to make sure that the outcomes of the earlier stages can be applied to the business in a useful way. Validation starts with a set of recommendations from the analytics and machine learning work. These recommendations are run through a SWOT analysis to make sure they make financial sense. Simulation can then be used to see whether the entities and the environment continue to behave on expected lines and the desired outcomes are achievable. A/B testing can be done to see initial user reactions to the new strategies and recommendations. Control trials can be conducted for this purpose. Finally, an action plan is arrived at with all stakeholders in agreement to deploy the learnings in production and reap the benefits. A data science process does not stop here. It is an iterative and continuous process of learning, validating, deploying, and improving. Business conditions keep changing, and the analytics process and models need to keep adapting to these changes to stay current and continue to deliver results.